All right. Good afternoon, everybody. We'll get started. This really is a case study on leveraging Sonic for a campus edge use case. And we have our friends here from Austria, all the way from Austria, Markus and Michael, who are going to walk us through their journey of leveraging Sonic in the data center and then how they're extending it to the campus. So we'll get started.
Okay, hello. My name is Michael, and I want to share the course of decisions of our university with our new network. So, okay, who are we? We are University of Applied Sciences. There are a couple of them in Vienna, but we are the only pure technical university. We have a strong focus on technical degree courses, computer science, renewable energies. But actually, we're quite a small university, 6,000 students, 1,000 staff. Yeah, as my part is not so technical, I want to share the course of decisions, how we get to use the network we are using and we are planning. So our IT strategy has a long-standing record of open solutions. And with this, we want to attract people in this field. And normally we manage to do this, not always. Recently, we extended our tool set. We're now running a Proxmox virtual environment as our virtual infrastructure hypervisor. We are using Ceph clusters and not a proprietary storage solution. And we have an exclusive use of OpenServer OS, which is Debian or Alpine Linux. Okay, just buzzwords are openness, in-house knowledge, and the cooperation with partners who support their open source products and even customize them for us. Yeah. So our partner today is Broadcom, Hasan. It's not always easy for us as a small university to get the manpower for customized solutions. So what are our strategies? We have training for new employees. Everything we can insource, we insource it. We cannot pay too much, but we offer space for playfulness. We honor creativity and individual initiative. So the way to new networking. I started at the UAS at 2018. I started with the only partly functional layer 2 network with a lot of end-of-life switches and a lot of outages. So it was clear we needed a new network. So, and besides openness, it was clear that we wanted to have a layer 3 network for scalability and resilience. And that we want to have, this is part of the playfulness, V6 in our new network. Looking out for open solutions and network disaggregation. We started with quite a mature solution, but after 1 year, we already had to running switches took the wrong way, so we couldn't use our planned hardware. And at the beginning of 2020, we had a little island of our new data center network with Enterprise Sonic. And since the end of 21, all our data centers running Sonic on edge core switches. So I will hand over to Markus.
Hello, everyone. I'm running the network team at our university. So we already had our data center and we have our old campus switches. So it's clear that we would like to have the same in the campus as well. And back then, Sonic was not really known for being a campus operating system. But yeah, we had the idea anyways. So, but let's start with a little bit of our history, where we were at the beginning. We had our data center, which was running on edge core switches. We have BGP there, EVPN and VXLAN, everything working. And for now, we have some test setup, partly virtualized with GNSC3, and some switches in one rack that simulate campus. There's already some devices connected to it, but we haven't really deployed a campus network, but we are very close to it. And yeah, next Easter we will have at least one building running it. Yeah, at the moment we're still testing it, improving our Ansible scripts and making sure it will all work when we actually deploy it. So now back to the history. That's kind of a bit of an overwhelming look of the topology of our old network. It's based on Cisco switches and quite old ones, and the colors here is actually, this is part of our handmade monitoring. The ones that are not blue have some problems. When I started, most of them were not blue, but we improved that a little bit. Also, we have to run one network while we work on the next one. And main problem is we didn't have enough fibers in the buildings years ago. So most floors are actually connected to the next floor and not to the data center. So those switches are in chains, one after the other. And by now they're at least connected to 2 data centers, so they're somewhat redundant. That also hasn't always been the case. So we are starting from a quite bad network, let's put it like that. And that's a little example what will get better with getting rid of the old network. At the moment we have kind of high latency and not much bandwidth because it's a layer 2 network, and even if you have redundant links, you actually don't use them. So surprise, sometimes the latency is quite high, like if you want traffic from one floor to the next one, that might take a quite long road. And also our firewall appliances are not really well integrated into the network and are kind of bottlenecks. That's also something we want to address in the future. So for this example, that's just the worst case scenario. You might see the red lines of how long the path for some traffic might be. And yeah, now we see that how it will look in the future. So this is also only excerpt. We have more floors, but remove the floors that are not relevant for this example. So in the future, all our switches will have a direct connection to the data centers, and there's our leaf and spine switches. At the moment, we are going for layer 2 still on the floor switches. They have an MC lag to the leaf switches. In the future, we want actually layer 3 all the way to the separate floors of our buildings. But yeah, that's one evolution of our network, that we won't launch it like that, also for compatibility with our current network, because we will not change every floor at once, so that will take a while. So, but yeah, in this example, in the future we will have less hops, and we have equal cost multipass, so the redundant links actually make things faster, which is a big upgrade to our old network. And yeah, so we will have much faster network. So in our new architecture, and maybe don't look at the graphic, more confusing than helping. So we will have a BGP underlay and overlay, mostly to keep it simple. So we're using BGP twice and don't have to train our people for multiple routing protocols. So we will have our EVPNs and likely for budget reasons, we will share the data center spine switches with our campus network, at least for the beginning, and then we see how that goes. So yeah, that's the whole thing. And so yeah, what are we hoping to achieve with our new network? We try to get rid of most SDP limitations and also most of our people in the support staff know how to run Debian and support all our virtualization hypervisors are basically Debian based and all our servers. So that's quite nice to have an NOS that also runs, that's a Debian Linux more or less. So that's one of the reasons why we wanted to have switches like that. We used to have 802.1x before, and we will still need it. And we already tested it. It mostly works, so it's quite important for us. We need more resilience. Mostly we get that because we also installed a lot of fiber in our buildings. So that's not a benefit of Sonic, but just we also invested into better cabling, and so we actually do have the fiber to be redundant. And with the layer 3 network and with VXLANs and WRFs, it will also be much easier to have some of our departments and institutes properly separated. And because at the moment, too many of them share the same VLANs. And one nice thing is, so far we always were very worried about when we have to do something about the switches, how much problems we have. So a warm reboot will be a feature we're looking forward also on the campus switches. And we have newer switches, that's a good thing. So,
quick time check. Please wind up in 5 minutes.
We'll hand over to him soon. And that's more or less a recap we already talked about. We also need better maintenance and monitoring, and are quite sure that that will work well. And and also long-term support, so that because our new network is like the old one, likely lasts us for 10 years or something. So at least that's what we hope for. So.
All right, thank you very much, Michael and Markus. And I just want to call out Kamran Naqvi was supposed to do this session. He's worked closely with these guys. I'm just filling in. Just a little bit about, a little more perspective from a Broadcom perspective, the motivation behind this. So, we've been involved with the Science Sonic project since 2016. About 3.5, 4 years ago, that's where we really accelerated our contributions. We are probably the first or the second largest contributor to this project over the last 3-4 years. And we heard from customers that they wanted to make sure that what they saw hyperscalers using, they wanted to apply the same principles of networking to their data centers and their networks, which is merchant silicon, open APIs, and open software. And that's where a lot of contributions focused on over the last 3 years. And you have heard from customers coming in here, from people like eBay who have a underlay network, BGP underlay network, to AT&T last year who have a managed service based on Sonic, to Line Communications probably a couple of days ago who have an L3 network, to a couple of universities. EPFL was here yesterday, and I would call Markus and Michael kind of pioneers on taking this to the campus edge. And one of the contributions that we had was just building the BGP VXLAN stack that continues to get contributed to the community. That allows you to make sure that you can eliminate spanning tree. You have no flood and learn, so the learning is much faster. You have a standards-based deployment, but also what you can do is you can have mobility, right? You can reuse VLANs, and one of the things that we have allowed in this architecture is that your access switches don't need to support BGP VXLAN day one, right? So now you can have a layer 2 access. This is what you guys have right now. And down the road, as you move to the newer class of switches, that's where you can move to layer 3, kind of to the edge down the road. And just making sure how operationalizing this, I'm going to just build this thing out. Similar to the approach that we saw with data center, when you're operationalizing these things, you have to have an ecosystem of hardware, you need to have the right functionality, and you have to have the right stack at the top, whether it's for management, whether it's for monitoring. I think the same approach has been there for the campus side, starting with making sure that, we're moving Sonic to kind of lower-end switching platforms, right? In our case, it's the Trident 3 and the X2 class of switches that are also used as management switches in the data center, right? So it was like really putting Sonic on a diet to make sure it can run on low memory footprint, lower CPUs. Moving up, wanted to make sure we ensure that the right functionality, starting with PoE, you are connecting devices, users, and things, so you have to have things like LLDP MED, to making sure you have the right security, from port security to dynamic ACLs, and the right authentication with the right feature set with .1x, and if you have, again, users and other devices and things, the MAC authentication bypass. The other thing is also important integration, right? What's the policy engine? You could be using anything which is custom from somebody like Cisco, like ICE or Aruba ClearPass, but as an open operating system, FreeRadius, which Technikum VM is using today. And lastly, making sure that from an automation perspective, things like Ansible can automate. And once we come here next year, you will see even cloud management solutions managing this network, multiple parties doing this down the road. And monitoring as well, you can use tools, third-party tools. There are plenty of companies out there that are doing it. You can get something from Broadcom itself, like AppNeta can run as a container. You heard Line yesterday talk about using multiple containers for monitoring. And again, support for things like ZTP. So
Thank you. I think
journey.
we are at time. Please wind up.
All right. I think anything you want to say? Yeah. I think a few things that Michael and Markus talked about, right, which is there is still work to be done, right? We will, things like warm boot and there are other capabilities will bring. You will see the ecosystem expand. And I think now you can actually download this version of Sonic, right? It's available. And you can also use simulation, right? Some of the links are given here. So thank you very much for your time.